Okay, so we have two more limit problems here. First one we have is an exponent. We're taking the limit as x goes to infinity of x to the 1 over x power. So first let's determine, is this indeterminate? Well, if we tried to do infinity, the exponent here is a constant divided by infinity, so that would tend to 0. And we'd be doing infinity to the 0 power. So infinity to the 0 power is an indeterminate form, so we can't answer that right away. We're going to have to use L'Hopital's rule. But the problem is that this is not a fraction. So we have to get it that way in order to answer this problem. So what you're going to do is we're going to consider that this limit is equal to some value that we don't know. I'm going to call that y for simplicity's sake, since we have x already in the problem. And what we can do is take the natural log of both sides. That's going to make this not an exponential term anymore. We just have to remember that we did the ln because that's changing the answer. We can fix it at the end, but we have to be careful of that. So if we take the natural log of both sides, we're getting that the limit as x goes to infinity of ln of x to the 1 over x equals ln of y. So we're allowed to do this because the limit operator can be distributed over anything. So even though we're doing like ln here, I can move the limit to the outside. So this is useful to us because now ln of x to the 1 over x can be simplified. This power can come in front. 1 over x can come in front. And if 1 over x can come in front, that's really written like this, because 1 over x means there's an x in the denominator. So now we're ready to do this limit. Now let's look at the limit as x goes to infinity of ln x over x. That's indeterminate as written because ln of infinity is infinity, and x as x goes to infinity is infinity. So it's infinity over infinity, which is indeterminate. But now it's a fraction, and we could solve that by doing L'Hopital's rule. If you watched the video for problem A, though, you heard me talk about how you can recognize that some functions are always bigger than others. And this is going to be another one that works out like that, in that just as e to the x was bigger than any degree of x is bigger than a natural log. So you'll see this by L'Hopital's rule, but another good thing to just keep in mind to make problems faster and also to check your answers, ln should always be the term that loses. So the bottom is definitely going to be bigger here, which means it's going to be 0 because the bottom is going to infinity more than the top. But let's use L'Hopital's rule to figure that out. L'Hopital's rule says that this limit is the same as the limit of the derivatives of the top and bottom. The derivative of ln x is 1 over x, and the derivative of x is 1. So I'm not going to write that on the denominator. So as we go x to infinity, you can see that this has just become 0 because the bottom goes to infinity and the top's a constant. So that would tend to 0. So this is where you got to be careful. 0 is not our answer because 0 is equal to ln of y. And remember, y is our answer. So y is equal to e raised to the power of this is e to the 0, which is 1. So remember, to get y back, we have to do e to the power of both sides. We get that to be 1, so our answer is 1. So that's just like how it was in problem A. This is a good trick to keep in mind that you can do some of these problems faster with. If you have any degree of x, that's going to be more important than the ln. That's going to be the part that determines the answer. All right, let's do problem D. Again, let's make sure this is indeterminate first. If we plug in infinity, we get infinity minus infinity in the numerator, which is indeterminate already, but it's also being divided by infinity. So this is definitely indeterminate. But let's think about what I was just saying in problem A and this over here. We have an exponential function, and everything else is just some power of x. You should be thinking about what I said in the previous problem. E to the x is going to be the determining factor of all of this because it's way bigger than any power of x. So we should think, before testing this with L'Hopital's rule right off the bat, the numerator is going to be bigger, so that should mean it goes to infinity, but let's see. So if we do L'Hopital's rule, this limit is equal to the limit of the derivatives of the top and bottom. The derivative of the top is e to the x minus 1. This would go to 0. The derivative of the bottom is 2x. And you can see this turns almost into exactly the same problem as part A of this. So this is still indeterminate. We do L'Hopital's rule again. That limit's equal to the limit of the derivatives, e to the x over 2. And that limit is equal to infinity. So again, recognizing that you know that exponentials are bigger than degrees of x and that degrees of x are bigger than ln's can help you answer these questions really easily without using L'Hopital's rule constantly. So keep that in mind, and you can always fall back on L'Hopital's rule, but you can usually answer them faster if you know those couple of rules.
The Teaching Center, UF's Learning Resource Center.